All right, hello everybody. Welcome to Map Time Davis. I'm Alex. I'm a Map Time Davis council member, an alumni. I work for a company called Development Seed. Let's get through some business. So today we're talking about Google Earth Engine. Before we get to that, Map Time Davis is a community run activity. Anybody is welcome to join us and participate. You can propose talks. You can apply for our council next year to help organize things. You can help organize things even if you're not on the council. All contributions are welcome. Upcoming on our schedule, in 2 weeks, we have Michelle giving a talk on, I forgot what the topic is now.
How will people know they want to come if we don't know what the topic is? So I'm going to be giving a workshop on how to create journal figures for maps, but it'll also be applicable if you aren't doing map figures for journals. A lot of the things I'm going to be talking about will also apply to things like graphs and charts and things like that. So come next in 2 weeks, we'll be doing map journal figure cartography with QGIS and open source tools.
Great. All right, so then we can get on to the main theme of today, which is Google Earth Engine. And so we've got Luke, he's a graduate student here at Davis. And let's see, Soils and Biochemistry graduate group. And he's gonna give us a crash course in Google Earth Engine.
Thanks, Alex. Thanks, Michelle. All right. Hi, everybody. I'm Luke. Yeah, I'm a PhD student, and my research focuses on land use change patterns in the Central Valley of California, which is one of the most important agricultural regions in the world. And I use Earth Engine to examine satellite images and classify crops in the region and to do change detection over time. And then I usually export those data sets from Earth Engine and work with them in R and use other data sets like soil type and water availability to examine how the drivers and consequences of land use changes across this region. So I'm going to take you through some of the basics of Earth Engine today. And yeah, I'll start with an intro, but before the intro, we should actually just double check that everyone has Earth Engine access. Hopefully you've tried to get access before this. If not, I'll send you the link now, and you may want to try and get it up and running while I do 5 to 8 minute or so background on Earth Engine. So try accounts.google.com and go through the email verification there if you don't have it and you want to have it for this tutorial. I'm going to live code a lot of the tutorial, excuse me. And you don't have to code along with me, but if you want to, I think it'd be helpful to get some practice typing in Java and interfacing with the Earth Engine software. So
I'll just remind UC Davis affiliates, your UC Davis email address will work because it is a Google account. And so if you're affiliated with the university, I suggest you use that.
Right, and there's sometimes confusion if you have multiple email addresses. So it can be helpful to just remember which email address you sign in with, or always try and sign in incognito mode or something equivalent, because Earth Engine is not great at noticing if you are using an alternate email address on accident. That can be confusing sometimes. So, all right, so I'll dive in first with a presentation. Let me share my screen. All right, how's that? Are you seeing my presentation mode or my notes?
Your presentation's up.
Okay, great. All right, so I'm Luke. The objectives of this session are to gain familiarity with Earth Engine, coding in Java, diagnosing simple errors in the Earth Engine software. I also hope that you gain access to Earth Engine resources, Earth Engine data, and also access to the community of people working with Earth Engine who are very helpful and will help you get through projects, because the third objective is that you gain enough confidence to have the willingness to dive into a battle with Earth Engine. And it's totally doable. So hopefully this will give you enough to really get started. I'm going to do about 8 minutes of intro first, and then I'll open up the software and walk you through Earth Engine and what it looks like. And then I'll do about 30 minutes of live coding, and you can follow along and code with me, or you can just run the scripts that I'll provide to you in a second. And then we'll take a brief break and then do about 30 more minutes of live coding. And so I think the whole thing should take about an hour and 15 minutes or so. And by the end of this, we'll have computed slope for the entire planet at 30-meter resolution using digital elevation data provided by the SRTM program. And then we'll also compute global NDVI at 30-meter resolution for an entire season using Landsat 8. So get pumped. It's cool stuff. We can do it relatively quickly. This is sort of the power of Earth Engine here too. Okay. And yeah, feel free to ask questions in the comment box, by the way. Michelle and Alex and Veronica can answer those for us as we're going, or throughout the talk. I'm also going to ask you for some responses, some feedback. Okay. And first, yeah, let's start with that actually. If you could please give me a thumbs up or a thumbs down. A thumbs up if you've used Earth Engine before, and a thumbs down if you've never used it before. And I'll be watching here. Okay, I see a few thumbs ups, a few thumbs downs.
So if you're looking for the thumbs up and thumbs down, it's in your reactions button on your Zoom toolbar.
All right, how about thumbs up or thumbs down if you've ever written code in Java before? Thumbs up if you have, and thumbs down if you haven't. Okay, great, thank you. How about a thumbs up if you are familiar with NDVI? Say you can, write the NDVI. Well, even if you've heard of NDVI before, actually, give me a thumbs up. If you've never heard of it before, give me a thumbs down, please. Okay. Okay, great. Thanks a lot. See lots of thumbs up and lots of thumbs down. That's good. All right, so I'll keep it moving here. So Earth Engine is basically a planetary scale platform for doing data analysis. Their goal is to help with managing a ton of data. They host huge amounts of data, more than 20 petabytes of data. You can access the data with relative ease without downloading it onto your own machine. And you can, run algorithms on it. You can filter it. You can do a lot of different types of manipulations to it so that you can get onto, actual scientific results and, discussion, that sort of part of the scientific program a little easier. Before this, it was much more difficult to get access to some of these images, global scale satellite data, for example. And this is really trying to make that interface experience a lot smoother. And on top of that, they are also hosting a lot of manufactured data sets, for example, land cover data sets provided by the USDA or other, kind of processed data sets. Okay, they're hosting, the program really started with Landsat, which I think is 30 plus years old. Since then, they're really increasing types of data. They now have MODIS, Sentinel, different terrain and land cover data. You can get weather and climate data. And there's more data coming in every day too, okay? And on this data, there are different types of data. First, there's images, like a Landsat scene, for example. There are image collections, like a season of Landsat scenes would be an example of an image collection. You can have features such as points or geometries or different types of geospatial features. You can have collections of features. You can do filtering manipulations on data based on metadata or distance from a point, for example. You can also do reductions on data, for example, computing the mean within geometry, or it's just one example. There are lots of different types of reducers. We'll get into a few of them today. You can do joins. You can export data. You can do classification via machine learning algorithms that are pre-built in Earth Engine. And you can manipulate projections. There's a lot of different possibilities, types of algorithms pre-built, and there's also the option to build your own within this software. And an example of a satellite image might at first look like this. And Earth Engine has often also processed these for you so that you can find them immediately with clouds filtered already. There are also examples of mosaics that are pre-built in Earth Engine that you can access. and also composites. And this, for example, is what is built to be the background for Google Earth. Okay, so some of the functionality in Earth Engine, you can get an image, you can customize your projection, you can specify, get different types of images with different resolutions. You can apply an algorithm to an image, and there's pre-built functions in Earth Engine that we can use, and we can also build our own functions. You can filter a collection of images based on time, space, or metadata. And then you can also map an algorithm over a collection of images. And I map on the computer science version of map. This is not a cartographic mapping. It's like applying a computation to a series of images is the I mean by map there. And you can also do reductions. Again, you can compute mean within a region. You can compute histograms across a multi-polygon. There are a lot of different types of reductions to do. And finally, you can compute aggregate statistics, and you can visualize aggregate statistics with charts within Earth Engine without exporting data. This is an example of NDVI throughout the 2016 year. And then you can also export data into CSV files or shape files or GeoJSONs, or there's different export possibilities. And I would say typically people are doing initial heavy lifting in Earth Engine and then moving into R or Python or whatever other software people are more familiar with, because I think Earth Engine is incredibly powerful and great, but it's a little bit less user-friendly than RStudio. I think in the past 5 years, RStudio error codes have become relatively easy to read, and it's become much more user-friendly. And I think my personal opinion is Earth Engine is a little bit less user-friendly. So it can be, typically we're doing heavy lifting in Earth Engine and then moving on to R, Python, or something else to do more of the analytical stuff. Okay, so that's it for my intro. Here we have links to, again, if you're still trying to get set up, there's some links there for you. And then let me post them also here in the chat. I have access to a very rudimentary GitHub page that you can access. And let me share that with you as well. All right, so here's can you all see that?
Yeah, we can see it, but the font's really small. So if we need to read it, you probably want to make it a little bigger.
How is that?
Maybe bump it up one more time. That's probably good.
Okay.
Is that okay? If anybody wants it larger, just make a comment in the chat. And
yeah, I sent the link too, so you can view this on your own machine as well here. Just have some tutorial scripts. So go ahead and click on that link, and that should open up a code editor for you. So if I click that. It should open up a blank code editor like this one. And then you should have reader access. So I'm the writer for this one, or the owner for this one. So I have this in my owner section here. But down where you're a reader, you should have access to this Maptime Davis repository. Imagine being a reader to like a Google Doc or something. It's kind of the same status. Yeah, so I guess it takes a minute to load. So I'll go slowly here. Take your time getting that up and running. I think it might be you, Alex.
Thanks.
All right, give me a thumbs up, please, if you have the Earth Engine tab up and running there. Okay, I see thumbs ups. Thumbs down if you're having an issue, or go ahead and ask in the chat for support if you need it. Okay, give me a second here to get set up, please. Okay, so for starters, here is Google Earth Engine. This is what it looks like. On the left, you have your scripts. I've worked in Earth Engine for a little while, so I kind of have a bunch of messes in here, but if this is your first time, you probably have a pretty clean little working directory in here. There's also access to documents in here, and these are pretty well documented. If you want to learn about things related to an image, you can click on that and scroll through it here. Say you want to compute pixel area, you can click on that, and it will give you some information on this. This one seems relatively vague, but you get the idea. There's quite a bit of help in here. And then there's also assets. These are all data sets I've loaded or data sets I've made in Earth Engine. And so you may have a relatively clean thing here too, but you can load data into Earth Engine and keep it there and do stuff on it throughout your career working in Earth Engine. Another thing I want to show you in scripts, if you scroll down to the bottom, there are example scripts here. So say, for example, I want to do an example related to, let's say I'll do charts and want to compute seasonal temperature. You can just click on that and it will put all this code in there for you automatically, and you can go ahead and just run that. And this one might take a minute. So this is doing, a lot of stuff here. I don't recommend starting by learning this way. However, as you go through Earth Engine, eventually you might start playing with these a little more and really taking chunks of code from these and putting them together in novel ways in order to make your own little project. Okay, so there's all of that stuff. Now, let's say I just want to get rid of this. Actually, I'll just delete this. This is the coding interface here. You'll do all your coding here. And in here, you have an inspector, which I'll talk about a little bit later. You have a console where errors will print. And if you do a visualization like this, those things will pop up here. You can, expand them by clicking there. And if you're running tasks, like say you're doing something relatively heavy and it's taking the Google Cloud that's doing computation a little while, it'll give you some information on that in this task area. And then down here, we have the main map of the globe. You can look around it like that. You can change to satellite view if you want. And you have different, capabilities here. You can make points here. I'll go through these in more detail later, but these are different ways to make geometries by hand. And then you have zoom functionality there. Okay. Michelle or Alex, is the font decent on this one, or should I try and work on that for a second?
I think it looks okay. What do you all think? Can you see it all right? You can put comments in the chat. Yeah, thumbs ups are good too. Not seeing any comments, but if anybody needs it adjusted at any point, let us know and we can go from there.
Okay, great. So I'll keep plugging along. So now we'll start live coding. So sorry, one second. If you go to your reader view of this MapTime Davis, we'll start with intro to JavaScript. Actually, I won't quite live code this one, but I'll just introduce you to Java now. So this is Java code. By the way, it is possible to work in Earth Engine via Python. I think it's not necessarily a beginner skill, but it is possible. We're going to stick with working in this API using Java today because it's much more simple, and I think it's also more common. I think it is also possible to plug in Earth Engine to R somehow, but I think that's also not necessarily a beginner program. Okay, so this is the API, and we'll be coding in Java. And in Java, comments look like this. You do the two slashes like that. You can also do multi-line comment where you start the comment with that symbol and end it like that. If you want to make a variable, you use this kind of syntax. Variable, the answer equals 42. You can make a string variable with quotations, and typically you end lines of code with this semicolon like that. You can also use double quotations to make a variable, and you can print stuff with the print function. So here we'll print a string. You can also make a variable that's a list, which uses square brackets, and inside of the square brackets, you can use single or double quotation marks for that. And then if you want to print an object from my list, you want to print the first object, you would use this syntax here. So you're printing my list, the 0 object of my list, which would be eggplant. So I'll run this whole thing here. If we go to the console, we can see all the stuff that this chunk of code printed. So first we printed this string here. This string will print in the console tab. We're printing eggplant, which is the first object of my list. We're also making another dictionary here with food is bread, color is red, and number is 42. And that will print my dictionary, the color. So that's another possibility with Java, is using that type of syntax. And Java has even more flexibility as well. You can also use print my dictionary dot color, and that will also print red. So that's why we have red printed twice here. Okay. To make a function, you can use the function. And in this case, we're making a function that is a string, and we're going to do hello plus the string plus exclamation point, and then print this function we just made and add map time to it. And that gives us hello map time exclamation point. Okay. So if, for example, on line 19, I miss a quotation mark, it will give me some hint that I have an error here. It throws all these crazy red X's. Or if I run this, I'll get here that I have a syntax error, string constant. It'll give me sort of a hint that it's near line 19. Sometimes this isn't always perfect, but that's sort of how error codes come through in Earth Engine. Okay. So put that back. Yeah, and that's it for that. So now I'll do some live coding. If you want to follow along, which I think I do suggest if you have this up and running, go ahead and make yourself a blank working space here. So you can do that by, you can just make a new tab if you want and type code.earthengine, and that should load a new one, or you can, working within your current working space there, you can just delete everything and don't save it. That's fine too. Okay, so I'll do this kind of live coding style. Feel free to live code along with me, or you can go to hello images. This first part will be working in this one for now. Okay. Give me a thumbs up if you're with me and ready to start live coding, a thumbs down if you're not ready, or if you need another minute. I don't see, okay, I see some thumbs ups. Okay, thanks. I appreciate the participation. All right, so we're going to load our first Earth Engine data set. Congratulations. In this case, I want to work with this digital elevation data set provided by the SRTM. So there are different ways to find data sets in Earth Engine, but this is sort of the most basic. You could just search in here, SRTM, and this is the one we want. So you can just click on that and it will pop up some metadata about this data set. It gives you a description here. You can check out what bands are inside of this. Oh, I'm sorry, data set. We can see we have one band, it's elevation. These are the min and max. The resolution is 90 meters and the units are in meters. Okay, there's citations, terms of use, there's other stuff here too. You can copy this code to import it, but for now we'll just do import, and that puts the SRTM dataset up here in this like little mini box above the code. And let's rename that one SRTM. Okay. You press enter on that. And now let's visualize it. So to visualize, you can use the add layer function. So we'll do map.add layer, open parentheses, close parentheses, and then just type the object there and press Control Enter or press the Run button, and that will visualize the map for you. So voila, it's really fast and easy to visualize stuff in Earth Engine. You can literally take one line of code, but this maybe isn't quite so useful like this. We need to get some more information out of this first. So, but quickly, I'll just show you that this is layer 1 here. So you can turn it off, turn it back on. You can change the opacity of it. And it's a little confusing. If we start making a lot of maps, that might be confusing. So the first thing we'll do is put a comma after SRTM and give this thing a name. Let's call it elevation. Oh, that didn't work. I think maybe it needs just a single parentheses. It's not happy, I think. Let's try that. Okay. This is a funky Earth Engine thing. You can't just give it a name without the curly brackets here. And the curly brackets are actually your visualization parameters. And this is like kind of a key part of making visualizations in Earth Engine. You always have to provide some visualization parameters, even if it's just open and closed squiggly bracket like that. But let's go ahead and add some. So we'll add a minimum of 0 meters and a maximum of, let's say, let's do 3,000 meters and run that. Okay, now this has changed the visualization here. So some regions are a little bit washed out, but it's pretty good. Another thing we could do is go to layers and click on the spinny settings icon. And now we also have some more functionality here. So this range we specified is 0 to 3,000 meters. We could make a custom one. Perhaps we want to just include 98% of the data. That will adjust the range for us, and then press apply. And now we're visualizing it with this custom range. Okay, it hasn't changed our code in here though. Okay. Please interrupt me if you need my attention, or if there's a bunch of things going on in the chat. I'm not quite watching the chat. So, so after this, let's take a look at the Grand Canyon. So I'll search in the little search box, Grand Canyon. And let's, I think, try that one. So that will take us directly to the Grand Canyon. Can zoom out a little bit here. Okay. So that's another possibility with that. And then let's add to this some water data. And for this one, we'll use, go ahead and Google JRC global. And that should start to pop up. I think we want global surface water mapping layers version 1.4. That should do. Take a look at this. Okay, in this data set, we have bands. In bands, we have a lot of different bands, right? So you can see there's actually quite a bit of information stored in certain images. And we're going to end up working with occurrence, the frequency with which water was present from 0 to 100%. Okay, but there's a lot of different types of bands within this image. So let's import this. That imports all of the bands. You can see there's 7 bands for now. And let's call that one water and then press enter. Now we have a new variable called water. And we also want to visualize this one. So type map.add layer, open parentheses. And because we have 7 bands, we actually need to now specify which band we use. So you do bands occurrence like that. And then, actually, I'm sorry, that's a visualization parameter. So that needs to go inside of squirrely brackets like that. Not the, no open bracket like this. Here we go. Okay. And then we'll specify a min. Let's do from 25% occurrence to 75%. Sorry, that need max there. And let's start just by running that and see how it does. I think we need to close parentheses there. It's not happy.
You forgot
we haven't given it an object yet. We give it water. And that should run. Not happy. What am I missing here? doesn't need a name, does it?
The error says that the band name is wrong.
Oh, okay,
I
thanks.
think you misspelled the variable.
2 R's, thank you. Not happy. Let's see here, what am I missing?
If you expand the
There we go.
variable, does it show you the band names?
How do you expand a variable?
On the import line, there's a
Oh, on the
little
import,
arrow.
yeah. Here you should be able to click here and go to bands and copy this. So I'm just bad at spelling. And then you could paste that here. There we go. So that runs now. We can check here. We have our SRTM. Let's give this one a name. So comma occurrence. And now we have 2 maps here. We can zoom in and take a look. Maybe let's turn off SRTM. Okay, so this river data set is showing up as white, so we do need to give it a palette. Within the viz params, then we can specify a palette with PALETTE. And to be pretty, we'll go from light blue to, these need quotation marks actually. Not happy. Sorry, give me a second. I'm feeling rusty with Earth Engine today.
Squiggly bracket inside your quote.
Oh, thank you. Appreciate it, Alex.
So while you're doing this, I was wondering if you could talk a little bit about how your zoom level in the map impacts how quickly you'll see results.
Yeah, good point. Here, I need to, I think I'm feeling presentation stress and not coding well. So let me just repaste this here. That should run. Okay, so as Alex mentioned, you can see I'm zoomed in here. So it's loading relatively fast. But if I were zoomed way out, every time you change the zoom, it has to reload, and it can take a lot longer if you have zoomed way out.
I feel like this is one of the most unintuitive parts of Earth Engine, which is that it will compute for whatever your map zoom is. So if you're zoomed in, it'll only compute the thing you see on screen, and it won't do the rest of it until you zoom out.
Mm-hmm.
And so
Yeah,
if you
exactly.
like zoom in and then pan over, it doesn't actually pre-calculate it. It only calculates it once you ask to look at it.
Mm-hmm. Right. Okay, so is everybody with me?
Yeah, there's a question in the chat about, can you explain again the 25 and 75 for the min and max? What is that occurrence data that we're looking at there?
Good question. So if you go back and click on our water variable, there's a link here. It pops up this little reader here, and we can get some metadata from this. So this tells us that occurrence is the frequency with which water was present from 0 to 100%. And I think maybe it's an annual image. So every year, depending on how much water is present in all of the images that are made that year, I think is how it's done. Oops, sorry. And we'll play with this in a second here too, so you can get a little more comfortable with that. Okay, so let's go back to the Grand Canyon. Like this one, I think is pretty good. So if we do zoom in here, let's find here's a tributary. If I go to my inspector, now you can click on the map, you get the crosshairs, and I'll click here, and this will give us some data about that point. So the elevation is 360 meters, and our occurrence data, we have 90% occurrence. So there's probably water there all of the year. If we click on this little tributary out here, now our occurrence is around 8%. So this thing maybe just has water, in the winter and spring. It seems like things are not going particularly well for the Grand Canyon waterway here. So yeah, you can, this inspector tool though is quite useful for just getting the lay of the land and kind of seeing what's coming out of these different data sets that we're working with. Okay. And as our scripts get more complex, it can be useful. There's not, our studio, for example, is becoming very nice to read if you're working in R Markdown or something, but we don't quite have that here. So you have to sort of make it readable on our own. So I like to do something, maybe let's put user interface down here, something like this at the bottom of most scripts. And then, we'll do some analysis up here. Okay, so now we're going to do our first computation Earth Engine, and let's compute slope. So we'll make a variable called slope, and say we're not sure how to do that. One place to go look would be in the documents. You could search in here slope, and there's a few different ways to do it. And we like this terrain.slope version. So you can click on that, and it will give you some information. You need to input an image, and it needs to be an image in meters, and it will return an image. Image is an image is an image, but Google Earth Engine means something pretty specific when they say image. So keep that in mind. So we'll use this ee.terrain.slope function, and inside of that, we'll pass this entire SRTM object, the object we made up here in our variable. Okay, and then you can put that at the end of the line, and now run that. I'm missing something.
You didn't actually assign the variable.
Oh, I'm sorry. Thanks, Alex. Okay, now we've computed slope for the entire region. And if we use our inspector, we should be able to get, we haven't printed it yet, but so keep an eye on that. And let's add slope to this. So actually, one thing that's copying and pasting is very useful. So we'll copy this entire line. And here we want to put our slope object. And then we don't need to specify a band inside of our visualization parameters, but let's do minimum of, say, 0 degrees and a maximum, let's do 55 degrees. And then I don't think we need to specify a palette for now, so we'll take that out. And then we'll give this one a name here too. So we'll call this slope. This should run. Okay, so now we also have slope going on here. So let's turn off SRTM maybe, and then you can see the steepness of these different canyons around the Grand Canyon. And you can see which ones have water and get an idea for how much water they have and what the slope is using this inspector. Okay. Any questions on this so far? I'm not seeing any questions. Okay, that's good. So I think in the interest of time and I think I'm feeling a little anxious, so having a hard time live coding. Let's just skip to the next part. In the scripts, we'll go to, sorry. I think we want part 3, apply a spatial reducer. And I'll walk you through what's going on in this code here. So we have the same code to compute slope. And now we want to do slope across an entire region. So this is our first reducer in Earth Engine. Okay, so, but we actually need to make a geometry in order to do this first. So let's go ahead and zoom in somewhere near the Colorado, and we'll make our own custom geometry with this button. And you can just click away freely and make any type of geometry that you like. We can change the color here if we want. Let's do Halloween orange. And then it automatically inputs this variable up in here called geometry. Okay, and we'll just leave that as that because this code is written that it accepts this geometry. Okay. Any questions on this? Sorry, this thing is zoomed in on me. I can't zoom out. There we go. Okay, so this should run. No. Okay. Okay, so hopefully that's run for you. And now you have this geometry, and we're printing our slope dictionary, which for some reason I think I have two geometries in here. Let's remake this here. I'm gonna make a new one. No. So delete that one. I'm having a little bit of a technical issue with that. So I'm gonna make a new one here. There we go. Okay, that's our geometry here. So run this. And now we should be getting inside of this, the average slope, because we've done a mean as our reducer function here of about 36 degrees. So this reducer here is taking slope and reducing a region across it. And the reducer we want to use is a mean reducer. The geometry we want is this geometry variable, which we just made manually. And the scale we want to compute it at is 30 meters. Okay, so that's how you can do a reduction. And then to print the result, we want to print slope dictionary here. We can also do a reduction on the water data. And for that one, you first need to select occurrence. We're going to do a filtering reduction where we take all the occurrence data where occurrence is greater than 90%, and then multiply back across the pixel area, and then sum all of those pixels where the occurrence water data is greater than 90%. Okay, so in our water dictionary function, you can see there's 0 area, 0 meters squared, where water occurrence is greater than 90%.
Hey,
so
Luke,
if I take,
could you talk for a sec about why you picked a scale of 30?
Good question. So this is a relatively small geometry. It'll do this relatively fast. You can rerun this. If you had a massive geometry, you need to reconsider scale because it can take a while for some of these computations to run. So if we were really trying to do reductions for like thousands of polygons, across the entire world or something, you can quickly bog down the servers and would need to either figure out a different way to do it or just consider using a bigger scale, basically.
How do we know what units that's in?
Another way so you can check the documentation here. So we could go to, I think this is working on the pixel area function here. So if you wanted to search that, I think that should pop up here. Okay, that doesn't specify, it does, yeah, square meters here. It specifies there. So that's one way to get an idea of, and Alex is right. These are really the tricky parts about working in Earth Engine is figuring out how to manipulate this code and what different things mean. So figuring out where to dig for metadata is definitely important. And a lot of stuff is in the documentation. And there's also a lot of good information online via Google that I'll sort of share with you a little bit later too. So if we want to move this, you can literally click and move this. Let's place it here and rerun everything. And now it should give us, yeah, there's almost 8,000 square meters of water that's greater than 90%. And let's say if we do want to maybe move it back here to one of these bigger tributaries, you can adjust things as you want. And then we could also, let's say, let's filter this to 50% instead of 90. And run that, and you can see there's still 0 square meters inside there. So let's maybe change this to 10% and see if we get anything there. Still not much water. So I think this place might be desperate for rain. But this is an idea of how this is a filtering reduction, still a reduction. The reduction, actually, I'm sorry, is really in the summation part. Okay, this is a filtering, and then we're doing the summation, which is still considered a reduction, and then printing all of the maps here. Okay. So I think let's take a break. Let's take a 3-minute break. What time is it? It's 2:50. Let's meet back at like 2:55 or so, and then we'll dive into working with Landsat. Okay, and feel free to ask some questions now if you want. I'll stick around. So, okay, see you at 2:55 then.
All right, we are back. We had a little bit of a discussion while we had the little break, and we wanted to talk about 2 things. We have a question in the chat that we were going to address, and then Alex wanted to talk about other data options. So I don't know what we want to do first, but that's the agenda, and then we'll get back to live coding. Luke, what do you want to do?
Oh yeah, okay, so Sam asked a question in the chat about, he says, Luke, could you talk about scale a bit more? What happens when it is changed to 60% or so? And so I think what you mean by scale is this scale here in the reducer, where we've specified 30.
Yeah.
Okay, and so if I actually think Alex might have a better answer. I'm a little confused by this. Honestly, I hadn't thought about it a ton before now. But if we search here in the documentation, reduce region, we can get the geometry reducer, and it does give us some information about all the different arguments that go through that function. And scale is one of them. And it's sort of vague to me, a nominal scale in meters of the projection to work in.
So
do you want to go, Alex? I could take a stab, but
yeah, I think it implies the size of the cells that you use in order to compute. So if you specify 30, I think it's doing 30 meter pixels across your polygon and sampling at that.
Yeah, that makes sense to me too. I think if you left it blank, it would work automatically in.
It has a default.
Yeah, which I don't know if the default is the resolution of the image or if it's something else. I'm not totally sure.
That's a good question. In this particular case, I don't know about this water data set, but as far as the SRTM data set is concerned, 30 meters is actually the resolution of SRTM. And so it makes sense that you would want to calculate based on 30 meter pixels.
Right, exactly. Yeah.
Well, that was my, well, I guess I'm going to continue on this question. So if the resolution of the pixel is 30, we essentially couldn't go beyond that, right? That is limited by the aerial imageries or the pixels, I don't know, resolution?
I'm not totally sure. Let's try. Let's change it to 60 and run.
But yeah, so 60 would work because that's 2 pixels. But if you go less than 30,
okay, let's try 15.
then it might work, but it scientifically speaking might not be right. Well, okay, so it would work, but what's happening is if a single pixel is 30, it's just going to divide it into 4 pixels.
Okay.
And so you're just going to get the value 4 times. So the computation is just more expensive.
Okay, gotcha. Cool, thanks. That makes sense.
Thank you.
All right, any other questions on this water and elevation stuff? We're about to move on to working with Landsat. So let me know if you have any questions on this for now.
I think, Alex, you wanted, when we were taking the break, you wanted to quickly mention some other data sources or competitors, other options.
I mean, we could probably talk about it at the end, but like, Luke kind of mentioned, there's a few libraries that let you use Google Earth Engine outside of this JavaScript live coding environment. This is great for demoing because you get to see the maps right away. But there is a Python wrapper and there is an R wrapper. I can go find the links while Luke's working. But then in terms of other platforms that are similar to Earth Engine now, Microsoft has one now called Planetary Computer, which has some of the same data sets. And then there's also open data on AWS, but there's no compute platform associated with it. It's sort of bring your own compute platform to the data sets that are on AWS.
Thanks, Alex. Yeah, I've been curious about that too. It seems like there's a lot more competition coming. So, and do you know, Alex, is Google working on Earth Engine actively, or are they just kind of maintaining it? Are they trying to make it better, or?
Earth Engine's interesting. So they now offer, it used to be that you could only use it for academic purposes, but they now offer a corporate license. So there are companies that are actually building their solutions on Earth Engine and they pay Google a fee. So it is monetarily sustained now. That was a question early on in Earth Engine, like it's like, who's paying for this? How long will it be around? And now there actually is a funding source. So as far as I know, they're still doing active work. I've seen them working a lot on their backend catalog. They've been upgrading their backend catalog to be more compatible with other services recently. So it does seem like it is still actively used.
Cool, thanks. Also, I want to show one thing before we move on to working in Landsat. If you're having issues diagnosing a problem, say, for example, we just have a typo here and run this, that's pretty good. That error code is pretty good, but oftentimes you get pretty confusing error codes and you can't run things line by line here. You have to run them all at a time with the button, or you can press Control Enter to run things. And typically I'll comment stuff out in order to single out the lines of code that are having issues. So you could just put the 2 slashes in front of everything manually, but that might kind of take forever. So I'll just Control Z. You can also like copy entire sections. And I think if you press Control C, let's try Control C, depending on your keyboard, might work. If not, you can do multi-line codes with 1 slash and an asterisk like this. So just put one at the beginning and end. And I think the order matters. It should comment out. In this case, it's commenting out everything. I just want to do this section. Something like this, maybe. There. So having a 1 backward leaning slash and an asterisk at the beginning and end of the code is another way to comment out entire chunks. I think there's some shortcuts for that. If you go here and go to general shortcuts, this will pop up a bunch of different shortcuts that you can use. But commenting and uncommenting is Command slash. It's just not working on my keyboard for some reason. So, okay. Any questions on that? All right, so I'll check the chat really quickly here. Okay. No questions in there for now, but I appreciate the banter. So for now, let's move on. Let's maybe just start a clean slate. There's different ways to do that. Sometimes you can just type in code.earthengine and go ahead and leave the space you are working in. And now we're going to start working in Landsat. So there are different ways to load images. Again, I think for now, I'll just show you this kind of clunky manual way. We want USGS Landsat 8, collection 2, tier 1, and top of atmosphere reflectance. So you can click that. This gives you some information on that. Inside of Landsat images, you have all of the classical remote sensing data, right? You have blue, green, red bands, you have near infrared bands, etc. There's other kind of quality stuff in here as well you can check out if you want. And we'll go ahead and import that. And let's call it L8. Press enter. Now we have 17 bands of Landsat. And let's go ahead and make our little interface here again. So we'll do map.add layer, and we should be able to just map all of L8. Sorry, there's lowercase a, I think. And that will probably take forever. It probably won't work actually, because it's the entire Landsat collection. So you might run into times where you've done something like this and you're kind of like not sure what's going on. But it's possible to make mistakes like this in Earth Engine, basically. So we don't really want to do that, right? So instead, we could filter this thing with a filtering function. So let's make a new variable called filtered, and we'll call that L8.filter. And in working with Landsat, it's most common to filter first by date. So we'll put in some dates here. So let's look at 2016-05-01. That will be the start date. And then the end date, we'll do single parentheses, quotation marks, 2016-05-31. So we'll look at about a month worth of images and run that. It's still not happy. Oh, I'm sorry, it's supposed to take filter date here. So run that. We actually still don't want to do this here. So we'll just run that, and nothing really pops up, but that's a good sign. That means it probably worked. All right, so now we can map the filtered variable and run this. And that will give us a global's worth of Landsat images for the month of May 2016. And you can see how these satellite images they're circling a planet with a revisit time of 2 weeks or so, and the images come in these swaths like this. And we're working with tier 1 Landsat data. And tier 1 is the good stuff, basically. There are other tiers. If you have really cloudy images or something's not georeferenced correctly, or there's some kind of issue, they'll often put it in a lower tier collection. So perhaps some of these spots where there's missing data, that stuff was not quality enough to be in tier 1, I think. Okay. Another thing we can do is print the size of this. So let's print filtered, and there's a function called the size function. So let's print that. Okay, we can see there's 14,000 images in this filtered variable. If we want to give this thing a name, remember we can do a comma there and type number of images, or just some way to give us some reference. So if we end up with a lot of things printed in our console, this will help us keep track of what's what. Okay. So moving on. Now we have this Landsat scene loaded. Let's go ahead and visualize in a more user-friendly way using some of our remote sensing knowledge. So on the filtered object, we'll give it some visualization parameters. We'll give it a minimum of, so this is sort of some remote sensing stuff. I don't have a great explanation for this, but we'll give a min of 0 and a max of 0.3. And then we want to give it, one second here. We want to specify which bands from this multi-band image we'd like to project. So we'll use square brackets for that. And to project an image that looks good to the human eye, we usually use band 4 and band 3 and band 2. And so that should run. Okay, now this is giving us that Landsat all those Landsat images in true color. And so it might be helpful if we give this map a name here. Like that. Okay, now we have our true color image over here. And again, you can change opacity if you want. And now on this scene, we can also make a false color image. So let's just copy all of that mapping code and go down a few lines and paste it. And to make a false color image, we'll start over here. We're going to use actually band 5 first, which is the near infrared, and then band 4 second, and then band 3 third, and we'll give this one the name false color, and that should run hopefully. Okay, so now this is kind of remote sensing theory. By changing the order in which you present these bands in Earth Engine, you can specify the how the image is visualized. In this case, I think near infrared is the reason why all this vegetated stuff is the color appears deep red, basically. And this is May imagery, remember? So these grassy hills out here are probably, I think in 2016 especially, were probably pretty green then. Okay. We'll keep moving here. So another functionality, because specifying visualization parameters can be often confusing, one thing that we could do is kind of make a variable called visparam. So let's do that actually. Let's cut this here, Control X, and paste it here. And then I'll make a variable called var vis. Let's do RGB vis here. And we have a min and a max. Just clean it up a little bit. And that should work. And now inside of here, instead of needing to have all the curly brackets and everything, we can just put RGB vis. Okay, so this is another way to make maps. You can do your visualization parameters outside of the map.addLayer function too. Okay, so there's that flexibility in there. All right, and now let's go ahead and zoom into our hometown of Davis, California. So if you want to turn these off, you can turn them off. You can zoom in on Davis, for example. Then you can go ahead and here, let's just turn on true color. And then we'll zoom in and let's pick a field that we like. So go ahead and zoom in somewhere and pick a nice field. So we'll take a point geometry. Let's pick this field. That one looks very square. And let's change the color, something funky for the heck of it. Okay, and now we have our geometry here, which is a point with these coordinates. And I think if you want to zoom to it, you can click that and it'll zoom you to it, and it zooms way in. So you might want to zoom out a little bit. You can also click this settings button and go back here, and this is a geometry, but you can do other stuff. You can change what type of geometry it is. You can change color. You can throw it away if you need to, etc. Okay, so here we are. Let's clean this up a bit. It can be clunky working in this interface sometimes, so I like to just do stuff like this to stay organized. So this is one of our constants now, the RGB vis. We have this is our analysis here. Okay, and then we're currently taking all of these images for May. We want to apply another filter to this one. So replace that semicolon with a period, and now we'll do a spatial filter. So we'll do filter bounds for that case, parentheses, and then type in here our geometry. And this geometry again is that point we just made manually. Okay, so if I run this, let's see what happens here. Okay, now we can see we have two images that cross this point within the month of May. Okay, so you can zoom out a little bit and see what that looks like. You can see we just have this one rectangular image here for that. So those are all the images that crossed over that point for the month of May 2016. Okay, and we have two of them. Let's say we want to just take one of those. We could put a period here and use the first function. I think we just type, let's see if that works. Okay, I think what it wants actually is so there are different ways to do this, but one way would be to just make a new variable called an image and pass to it. We'll need to use this image function and give it filtered.first like this. That should run. And then we could also print image.size like this. And just call that image. That should run. It's not happy. Maybe a typo and I'm having a hard time spotting. Why is that not happy? 1 second, please. Okay, that should work. Image.size is not a function. I'm not sure why that's not working, honestly.
Is size a property of an EE image object as opposed to an image collection?
I thought it was. Anyway, yeah, that's probably it, actually. That's probably it. So thanks, Alex. I'm feeling rusty with Earth Engine today.
When I took out the parentheses after size, it ran, but I don't know if it's giving me anything that makes sense.
Oh yeah, if it's a property and not a function, then just take the parentheses off. So image.size and see if that exists.
You're saying just run this like that?
Oh, no, you can do it as a print, but don't put parentheses at the end, I think is what Michelle is saying.
Yeah, it ran, but I think it's telling me it's undefined.
Oh, okay,
yeah.
so it's not a property.
Yeah.
Okay. Anyway, I'll pretend this never happened.
It's fine.
And,
it's good learning curve for us to see what happens when we make things up and then we troubleshoot it. So it's a good lesson.
So, okay, so there's still two images in. No, okay, here we have there's two images from filtered. So let's clean this up a little bit. And then we'll also make image and just print image. And here is this image. And you can kind of check some stuff out with this one image we've selected now. So we have all of these different bands there. There's these different properties from that image. It's a type image, which is part of the reason we use this image function or in order to do the, I'm sorry, maybe that was my issue. I wonder if specifying that would work. Okay, anyway, this is using this console here, you can get a lot of information about that image you're now working with. Okay, and then within this image, we can do computation. So let's do some of the classic remote sensing computations. We'll take we'll make a new variable called near infrared, and we'll take that image we just made and then select band 5 from it. Why am I so bad at coding today? Oops. Okay, we can also make another variable called red, and we'll do image.select, open parentheses, band 4 for red. And while we're at it, let's just copy that, make a new line. And in here, we'll put, actually, no, we're gonna do something different there, I'm sorry. So go ahead and run that, make sure those two work. And then we'll compute NDVI for our first time. And to do this, we can take the near infrared object we just made and subtract from it the red object, and then divide by near infrared plus red. I think that should work. Seems happy. Okay, so now we've made an object called NDVI, and we can add this to our user interface. So let's map NDVI here. We'll do map.add layer, put NDVI there, and you can run this and see what happens. But it's probably not going to be super easy to visualize. So let's go ahead and add some curly brackets for visualization parameters. And NDVI in theory is kind of a vegetation index that basically quantifies, how green or how much chlorophyll is in a plant. And it goes from -1 to 1. So let's just visualize from 0 to 1, and we'll call that NDVI, run that. And now we should get NDVI here. Let's turn these other ones off. Okay, now we have NDVI for this entire image that we've just done. And again, if you wanted to take your inspector crosshairs, you could click on a field and it would give you some information about NDVI here. It gives you a lot of information about all these different bands from the image as well. So you see we've computed NDVI here. There's a lot of stuff going on in here, but it's good to get to be familiar with all the different functionality coming out of this inspector. Okay, so this is also here, this line of code is to showcase that Earth Engine can be used as a calculator, basically, if you need to. But people have been working in Earth Engine for a while, so people have made functions and normalized, NDVI is one of the most frequently used remote sensing functions, at least for environmental science or plant sciences, which is sort of where I'm coming from. So another thing we could do is compute NDVI with the normalized difference function. So we'll pass it the same image, which again, right, is this first image that we made right here. Okay, so we'll pass it that, and then we'll use the normalized, I think capital D, difference function. If it turns purple, that's a good thing. Give it parentheses and give it square brackets. And we want to pass to that band 5 and band 4. Okay. So if you run that, that should be happy. And let's go check out the normalized difference function here just to make sure we did this right. Okay, so it's good to get familiar with this documentation here. So type in the documentation, normalized difference. Okay, you can see this is an ee.image function. Click on it to get some more information. And we can see that it computes the normalized difference between two bands. And it's computed as first minus second divided by first plus second. Okay, so that's why we fed this thing band 5 and band 4 in that order. That's how normalized difference works. If you're not familiar with NDVI, that's totally fine. But it's basically an index that shows how green the pixels are. And in this case, everything, let's show only NDVI, everything's showing up kind of white and black. And so it would probably be helpful if we changed our visualization parameters in here by giving this thing some kind of palette. So I think what we want to do is let's try putting a comma there and doing palette. 1 second. Okay, and then for palettes, you need open parentheses, and let's do black to green, for example. And that's kind of how, I'm sorry, it's a comma there. Black, comma, green. That specifies the beginning and the ending of the palette. And we'll look only at NDVI again. Okay, and so now we can see that green is where there's high NDVI and black is where there's low NDVI. And I think we could change this to light green like that. And that should look a little better. Okay, there we go. So now we have NDVI with decent visualization parameters for that entire image. And you can kind of zoom in here and try and pretend you understand, you have an idea of what's going on, right? So there's a lot of fields in here that are black. That means they have really low NDVI. This is actually the rice growing region. So these things are probably flooded in May. Remember, we're filtering, we're looking at 2016 May images here. Whereas I think that was a rainy winter maybe. So out here, you know, the chaparral is relatively green, and like the hills around Davis and Sacramento are relatively green. I think probably in this image is why those have relatively high NDVI in May. Okay. Another thing you can do, and this is not a very scientific approach, but it's a pretty handy way to kind of ground truth stuff and get an idea of what's going on if you're visualizing something. You can just turn these off or toggle it on and off, and also check out the satellite image here. And this satellite image, remember, is made with like a composite from all the prettier, you know, all the higher quality Landsat images taken that Google has kind of composited these together for us. So if we do want to look at this rice field, it looks like, you know, some of these were flooded and some of these were half flooded and some of these were dry. And we can kind of like get an idea of NDVI in them. The background satellite imagery, we don't know when that's from. You could probably figure that out if you really dig into it, but it's just a way to kind of get an idea of what's what. You can see some of this stuff is like orchards, and near the river, there's often these little like wetlandy, shrubby, bushy areas sometimes, and kind of get an idea of how NDVI looks in all of those areas. And you can see the river is black because it absorbs a lot of, it's, you know, water is relatively absorptive compared to a plant or to something else. Okay. So now what we're going to do is expand our use of the NDVI function a little bit here. So I'm going to go ahead and comment these out because we don't need these for now. Can keep that one. Let's make some space here. Actually, we'll keep those together, and we'll just make some space at the top of our analysis section. And now we're going to make a function. We're going to make our own custom function. And the point of this function is to add NDVI, add a band back to the image. And the band we want to add to it is NDVI, which we will compute. So we'll call our function add NDVI, and this function will accept an image. And then we'll open with a curly bracket. And you can see it autofills the backend curly bracket there. Okay, so now we'll make a variable called NDVI. This has nothing to do with this variable NDVI. This is just practice at this point. We'll comment it out just to kind of leave it behind while we move forward. And that variable will take an image and will compute the normalized difference of band 5 and band 4. Okay, that's kind of like we did it as we did earlier. And it will run an image, and to that image we'll add the bands, NDVI. So whatever image we pass this thing, we're going to end up computing NDVI and then adding to the image a new band called, and that band will be NDVI. And for the sake of staying organized, we'll rename it with the rename function. Oops, sorry. And just call it NDVI. Okay, and I think that should be happy. No, I'm sorry. I think we want syntax like this. Okay, so now I think that seems to have worked. NDVI is not defined. Actually, it's not happy. So what did I do wrong here?
Yeah, that line right there.
Thank you. Normalized difference. Okay, that should be happy. Okay, and now let's take our filtering procedure. We can comment out. We don't need to print. Actually, let's print that for now. Let's expand this. So let's look for the entire growing season. How about we'll go from May 1st to August 31st. I think let's just do 30 just in case. And let's remove this geometry filter. Okay, so we don't need that anymore, and we'll replace the period with this symbol. So we're no longer taking the images that were over that point, and we're also expanding this to include the entire summer season for 2016. Okay, that should be happy. You can see we have a lot fewer, no, we have more images here now. And then, so I'm going to comment this out just to stay tidy. We'll make a new image called variable. Let's do with NDVI, and we'll give our filtered object that we just made in line 14 here, right? So we'll take that and we'll map back across all of the images in that collection our add NDVI function like this. Again, this is not like a geospatial mapping necessarily. It means basically apply to this image collection this function here, add NDVI. Okay, that's how that works. And this is a really common feature. You know, this is something we do, at least I do pretty often in Earth Engine. This is one of the most common types of things you do. You collect a bunch of images and then you do a computation and you map it back across a number of images. Okay, so it's good to get familiar with this mapping function here. Okay, and that should be happy. And so one thing we could do is let's go ahead and add our NDVI map back to it. But instead of this one, we want to map with NDVI here. So this is going to map an image collection. And if you do that, it should work, but it will automatically print them in order, and there's tons of images. So it's best to add some kind of reducer here too. So we'll just take the median. And also we need to change. Let's change these visualization parameters to our RGB viz that we made earlier. And this will be an RGB image. I think this should work. Seems to be not happy. Okay, so this is now printing from an image collection, which is NDVI, it's printing the median image. If we were to print, let's just do print with NDVI. This might take forever. Yeah, see, there's so many images there that Earth Engine doesn't want to do this task for you. So we can often, let's see what's a good way to, let's not bother with that for now, I guess. And we'll also add to this. Let's copy this visualization setting here. We can do away with these visualizations for now. And we'll make a new visualization parameter here. And let's do, like we did before, a min of 0 and a max of 1. And a palette will be black to light green here. And this one we'll call NDVI. Seems to be not happy. So I think it was having a typo there, so I just copied it from the documentation. But okay, so now we've computed, we're visualizing the RGB images from the entire summer of 2016 and the median NDVI from the entire summer of 2016. Okay, so now you can zoom out here and take a look, and we've computed median NDVI for the entire globe from the 2016 summer season. Okay. Any questions on this? Let me know if I should proceed forward. By the way, in the scripts now, we should be on, we've just finished with map a function over a collection. So that's kind of where we're at now. Okay, and then we have one more. So another useful function in Earth Engine is to get some data from this image collection. And to do that, there's within print, we can use print parentheses. There's this UI.chart functionality. So you can do UI.chart. It's going to take an image and then .series. And we can pass to that series R with NDVI object. And we only want to select the NDVI band. So we'll pass it also .select NDVI. And that's the band name that we made up here, remember, in our function. And let's just do that for our point here, for our geometry. Okay, so if we run this, it should generate for us a chart of NDVI for that 2016 growing season. So if I want to expand this, you can see this is our time series of NDVI. Okay, so you can see like planting season happened around here, onset of greenness came in here, and then we have peak NDVI sometime like late July, early August. Okay. Sorry, where was I? Okay, so that's pretty much it. Yeah, that's the whole tutorial. Let me know if you have any questions on this for now, and then I can do some kind of wrap up. I'll point you to some resources to help you get going and continue working in Earth Engine. So thanks for your time. Yeah, any questions?
Not seeing any in the chat right now, but folks, feel free to put some questions in the chat, or if you'd like, you can unmute and ask them verbally if you want.
I'll check the chat really quickly here. Seems
Here
like
we go. Here's one.
Okay, so Sirapum is asking, could you go over how to filter by country or administrative boundaries? That's a good question. So if you're trying to do something rudimentary, for example, like you have, let's say, there are like 5 fields out here somewhere in the Central Valley that I know that I care about. You could make geometries simply like this. You and do your science this way, right? That's one way to do it. And in some cases, like that's a totally reasonable way. It depends how many fields you have, of course. If you're trying to do something much bigger, much more complicated that involves, like state boundaries or county boundaries or watershed delineations or something, you need to import data. And to do that, you can do that in your assets, right? So I have all of these assets I've loaded here. These are all like shape files or, different types of spatial data. You can upload raster data as well, but typically what I'm doing, for example, is I'm working with a field boundary data set, and I'll import a shaped file into Earth Engine and then compute reductions across all of the like thousands of fields in my study area. Yeah, you can import SHP. So you just typically go to new, and you can upload something here. You can upload a shape file, and you can go and select it. You can give it an ID so that it ends up in a certain folder in your within your little Earth Engine directory. And then you can add some other stuff here and then click upload. And sometimes it'll take, depending on how big it is, it'll take a little while. So it's something you can do like during lunch break or, before you go to, quit for the day or something like that. You can leave these things running. That's a good question. Any other questions?
I'll just point out that there is some global administrative boundary layers in Earth Engine in the catalog. So if you just want to pick out one country, you can just import directly from the data set that they already provide.
Exactly. Okay, so I'll go on to showing. Let's go back to my, where is that? Let me pull up that GitHub page I sent earlier. I'll send the link again to you in a second. Okay, there's the link to the GitHub page. And so these are the reader access to the scripts again. And then there's some resources in here for, oh, sorry. Let me make that, there we go. Now you can see it. Okay, so these are videos that I basically modeled to make this tutorial. These are longer and a little slower and more thorough, but very similar. And they also go a little more in depth, and there's like 5 or 6 more parts beyond what I covered today. So I definitely recommend those. I kind of cite them too. Those are really my source of inspiration for this tutorial. And then inside of Earth Engine's webland, they've built these Earth Engine guides. So let's open that. This is all Earth Engine documentation, and this is really quite thorough and well documented. So if you want to learn about doing something, like working with geometries, you can go here and it will give you a lot of information on geometries. You can copy code from this and paste it in your editor and run it and see what's going on. There's a lot of, all this like documentation on reducing, raster to vector conversion, vector to raster conversion. There's a lot in here. This is really quite useful. For my projects in Earth Engine, I was always running these, taking lines from them that I thought would work for mine, and then playing with them as I'm trying to work through my project is sort of, that was sort of my workflow for like learning and doing Earth Engine. Okay, so go back to the GitHub page. In here is the data catalog. So let's open that one. This is all of the tons and tons of Earth Engine data. And this is like quite well curated, I think, as well. So if you work with Landsat, you could click here on Landsat. And there's now Landsat 9, 2021 to present. Say we're interested in that. You can click there and learn more about it. There's surface reflectance, top of atmosphere images. There's raw images. Let's take TOA. This gives you also here all this data. And then you could also go ahead and copy this and run it in a blank script, and it will load some images for you with these dates. It's selecting band 4, band 3, and band 2. And they're making their visualization parameters here, and then building this map out. Okay, so you should have a pretty good understanding, I think, after today of how to start to load data this way from the tutorial as well. And then let's go back to GitHub. I have to plug the geospatial listserv, as I think Michelle would appreciate it too. There's a lot of great people on here. And I rarely post questions, but I often follow what people are posting and talking about. And it's a good way to learn. It's a great way to post code questions, get advice, and there's job postings on there, etc. There's also this new Earth Engine textbook, which I just discovered this morning, actually. I think a bunch of scientists from around North America got together on this and have built a quite impressive textbook. Okay, so there's part 1, like basic Java, exploring images, some of what we did today. And they're also working through all of these advanced topics. There's multiple parts. There's a lot going on in here. So definitely check it out if you want to look at section F5, for example. It's quite beta. I love it. It's like Google Docs here. It's awesome. So this is worth some time too. I think if there are specific things you want to look for how to do, I would maybe like try sifting through this textbook as well. Okay. You can also reach out to the authors of it with questions if you need. And then I didn't show this earlier, but the coding software itself is rather clunky. Like it's great, but it's not something you necessarily want to share with a land manager or a collaborator who's not super familiar with programming or something. So if you want to, you can make apps. And these are some example apps. Like this one, for example, is giving you MODIS ocean temperature. You can zoom around on it. I think in a second it should load for us the data. So it's gonna, maybe we'll have to zoom into. It's taking a second to load, but anyway, it's going to give you global Earth ocean temperature data for 2017, and you can use the inspector to click on it, and it generates this type of chart, based on how they built the app. So if you're in Earth Engine land, you can have this script here, and then you can go to this apps button and walk through how to, the process of turning your script into an app. And there's a bunch of examples in the GitHub page. Where is that? In here, in the link from the GitHub page on different types of apps and how they can work. Okay. So any other questions? That's really all I have. Yeah, so
one question came up, which I partially answered in the chat, which is about export options, about how to get your data out. If you want to talk a little bit about how you normally work through that.
Sure. So most of the work I've done has involved reducing to field boundaries within the Central Valley region. So there's, I have like 30,000 fields or so, and I like to get field level information typically. And one thing that I do is, I'm working with raster data to do classification of the crops across the region. And then I'll overlay the field boundary on that and compute a histogram for the frequency of the different types of crop classes within that field. And so you can get, it's not a mean, it's a histogram reducer basically. And from that, I would reclassify the fields. So if within a field boundary, 85% of the pixels are, let's say, rice, and then 15% are like other random crops, I would reclassify that entire field in R. I'm doing this reclassification part in R. I reclassify that entire field as rice. So that's kind of one example of what my workflow is like. I'm not exporting raster data explicitly. I'm exporting a field level reduction of raster data. Alex, I don't know if you have a good example of how to export raster data explicitly.
I mean, I mentioned it in the chat. There's 3 general options. One is an asset, which isn't really an export, but it's you can save the results and use it elsewhere.
Exactly, yeah.
And then there's an option to export to a cloud drive. So if you have a Google Cloud account or an Amazon account or a Microsoft account, and you want to use their bucket storage, you can put it to there. The easiest one, which I mentioned in the chat, was you can save to your Google Drive, which works great for smaller things. If you need to do bigger things, you really should look at the Python or the R libraries, because they'll have it built in so that you can pull it to your local machine and it'll script it and it'll do it in bulk in the background, which there's a whole API for it on the back end that I've worked with before.
Mm-hmm.
It's kind of a hassle if it's very big. I think I did a 30 meter for the whole world or something, and it took a long time.
Mm-hmm. Yeah. I haven't done many huge ones. I've been able to do all of mine into Google Drive.
Yeah, doing like California with like a one band raster, it shouldn't take very long. That's pretty straightforward.
Yeah. And if it is taking long, I mean, it's potential to do more computations in Earth Engine to try and reduce the size. But there's also this trade-off of, working in Earth Engine, which I think can be relatively difficult and clunky, and then like exporting and getting something into your, onto your own machine, or something that where you can interface with R or Python a little more like you do normally. So I think finding that tipping point in your workflow is also kind of part of the learning process. Any other questions? I see Emma's asking about LandIQ. So I'm using LandIQ. Yeah, is a training information for my work at least. And then I'm using their field boundaries to reclassify my land cover information. So there's a lot of different, in my case, I'm working in the Central Valley where there's quite good data already. Like there's USDA crop data, there's LandIQ data, but I still have ended up with custom enough kind of scientific questions that I've reconstructed some of my own maps. And to do that, I trained in Earth Engine. I built a classification with LandIQ training information, and then build my own crop map in Earth Engine, and then overlay the field boundary, and then export the field level information, and then work from there in R on my own machine. So that's an example of my workflow. And yeah, definitely using LandIQ. LandIQ has a really high quality map, so they're also kind of expensive, but you can find their information's floating around UC Davis, and I think that DWR is also now posting some of their data sets online for free.
All right. I think that's a wrap for the official session. We can go ahead and stop the recording.
Yeah, so before we do, I just want to say thank you, Luke. This was super awesome, and I'm glad we did this intro again, because I think I'm understanding more and more about Earth Engine every time we do this. So I really appreciate this. So thank you.
Yeah, for sure. I'm happy to do it. So thanks for having me.